Okay, hi everybody. Welcome to week 3, lecture 2. Today we're doing a really important topic called arrays. So arrays will be something that we obviously look at in the lecture today in Shoots and Labs, but it'll also be a large part of the first assignment that comes out next week, and it's also one of the hurdles. So we want to give you lots of opportunities to, and lots of time to get on top of this topic. So yeah, it's an important one, and it's a really useful topic as well. So last time we did enums and functions. We talked a little bit about good style. Actually, we talked more about bad style, right? I showed you that program that I really love. Today we're going to do a bit of a function recap. I'm going to show you just 2 little pieces of code shorthand that you can use or not use, and then we're going to go into arrays. And if anybody notices I'm not doing it, feel free to let me know. Okay, so this week, there's a few announcements. Hands up who's gone to some help sessions already. Has anyone gone? Onto the online ones? And at the moment, they're not super busy, are they? Okay, so now's a really good time to go to the help sessions. So get in early, get help early, and you can get help later too. So next week, after this lecture on Monday, the first assignment will be out. I don't want to spoil it, give you any spoilers yet, but you'll find out on Monday. We will run a special live stream. So on the Tuesday, not in the lecture slot, but on the Tuesday at 12:30, and we'll send out all the details, you'll have a link to go and watch the live stream, or you can watch the recording of it later. We know you might have other classes on at that time. And it's just going to step through that assignment specification in more detail, right? So ideally, when it comes out on the Monday at 1 p.m, I mean, not right at the dot of 1 p.m. do you have to do this, but ideally before that live stream, if you can have a bit of a look at it, so then you're going to know what to listen out to in the live stream, and you might have some questions ready to ask in the chat, or the sooner you read it, the sooner you can understand what you have to do, and the sooner your brain will start, realizing in your tutes, in lectures, oh, that might help me do that bit. That might help me do that bit. I need more help on that bit, okay? So don't avoid it. And I'll talk more about avoiding things later. So the sort of material that you need to know for the assignment is basically everything we've done up to and including actually next week as well. So things we haven't done yet. So all the basics, obviously, functions, while loops, if statements, structs, enums. You'll need to know all of that. Shh, shh, shh. Everyone be quiet while I do this. Shh. Hey, shush, shush. So thank you for helping me shush. So yeah, material from lectures in weeks 1 to 4 are important. We're also going to do in the week 5 first lecture, the Monday lecture of week 5, which is actually a public holiday, so I'll pre-record a video. We'll go through a sort of larger example, so a bigger example than we normally have time to do in lectures, where we put all of this stuff together, and that hopefully will really help you put it together as well and help you do the assignment. The other thing is, hands up who's checking their UNSW emails regularly and who's getting the forum announcements. So there's lots of stuff that we'll be sending you through the forum. So if you're not getting the forum announcements, just do something about that. If you're not checking your UNSW email, please do as well, okay? All right. So we're also running, a few announcements today. We're also running revision sessions starting next week. Well, actually, we've got some on next week. They're basically on in week 4. When's the next one? Yeah, week 4, 6 and 8. So next week we've got some on Monday, 9 to 11 in person in a lab. Wednesday next week and Friday next week online 12 to 2. So you need to sign up for them. Now the link to sign up is on the forum and I've put it here as well. There's also voting for topics. So if you go to the forum announcement, it'll let you vote for what topics that you want to spend the most time on in that revision session. So some of the topics are, you know, just pretty much all the topics we've done. So vote for the ones you want, sign up for those sessions. There'll be different sessions running in week 6 for slightly different topics because we will have done more topics by then. All right. And these are just optional. You sign up and Sophia, would you say it's run more like a tutorial or a lab usually? Or a cross between the two?
Tutor guiding through questions that are similar to lab style questions.
Okay, yeah, so it's sort of like a tutorial experience with lab style questions, yeah. So I think it's really, really valuable. All right. As always, we've got links to the live lecture code. So we're going to do a bit of a function recap. Now, this first thing I'm going to show you is sort of just the high level view to remind us why functions are good. So if every detail of code is still a bit tough for you in this example, that's sort of understandable. But we went through, and you can't even see this code properly because it's probably, or maybe you can, but we wrote all this code to do with a struct Pokemon that had an enumerated type as one of the fields. And even just trying to print out the details of this Pokemon, we ended up with this really big main function. And we ended up, you know, copying and pasting and duplicating a lot of code. Okay, does everyone vaguely remember this example? Then we looked at how we could break it up into functions. So we created a function that could print out a type for our Pokemon. So then, instead of having to copy and paste that again and just change it slightly, because our Pokemons had a primary type and a secondary type, we could just call this function twice. So we also we packaged all of this stuff up into a print Pokemon function, which actually then calls that type function as well, print the type. And it resulted in us having a main function that looks like this compared to a main function that looks like all of this. So I didn't package this little part up into a function, but just from doing that one print Pokemon function, we've got a main function that's a lot more readable. And we call this, well, I guess we've saved the duplication of code, but we've also got something called abstraction. So if I'm reading the main, I see print Pokemon. And hopefully if you've got a good function name, you'll be able to read that and think, oh, it's going to print out details about the Pokemon. Your mind doesn't have to be overwhelmed by all of these sort of lower level details when you're just looking at the main function. Okay, so this is kind of these are the good reasons for using functions. All right, also, once we're pretty convinced that we've tested these functions and that they work, they're less likely to be a source of error in our programs. So we can test these pieces before we start adding more to our program. So these are just the benefits of functions. So does anyone have any questions about why we might want to use functions? So I think I've mentioned all of those. And also the function is just a block of code that performs hopefully just one specific task. If it's doing all sorts of millions of different things, you possibly need to break it down into more functions, okay? It shouldn't be printing out the Pokemon and also, I don't know, I can't even think of what else it might be doing, but doing something else completely different, random, you know. Okay, so I'm going to go through some of the sort of finer details that I kind of mentioned last time, but I probably didn't go into, like, focus on it. So I'm just going to show you an example, not this one. Let me get rid of this. I'll hide that bit there. So here's an example of, this is just a really simple function, right? We've got a function. What's this thing up the top called? Does everyone remember? Or does anyone remember? Yeah, we call this a function prototype. And this is telling us, and also the compiler, that there's a function called add numbers. That's the name. That function expects 2 inputs, and the 2 inputs should be of type double. And then it's going to return some kind of value, and in this case, it's going to return a double value. So when I use this function, I give it 2 doubles, it gives me back a double. I say add these 2 numbers, and it gives me back the answer, it returns it. So I just want to illustrate what's happening here. I just want to open my pen. Oops. Oh, that's all right. That was just the forum. Okay. So we've got our main function up here. Actually, I'll use a different color. We've got our main function up here, and in memory, we have a chunk of memory that's dedicated to the variables that are used in the main function, okay? So we've got these 2 variables here in the main function. We call these local variables. So local variables are basically ones that we typically think of them as ones that we've declared inside a function. So this double variable n exists inside the RAM that's dedicated, or the memory that's dedicated to the main function. We call it a local variable. It can be accessed anywhere between here when we declare it and this closing bracket. So we can access n anywhere from here to here. So it's local in scope to this main function. Does that make sense? Sort of? All right, and I'll show you in a minute some more details. And what we've done is we've set this value to 5.5. Okay, now on the next line, we're doing a function call. And we're saying add numbers, go and add these 2 numbers together. I'm passing in n, but it passes in the value that's stored in n. So it passes in just the value 5.5. Now when it does this, the add numbers function has its own section of memory with all of the data it needs. So it's going to have, we call these parameters, but it's going to have an x, and that x is going to have the value 5.5 in there, right? So in the main, that 5.5 was stored in the value n. We've passed that value 5.5 into that add numbers function, and it's stored in the x parameter. Is that okay so far? We do the same thing for here. This isn't even in a variable, it's just hard-coded. We send it in, we get 1.5, and inside the add numbers, it now has x and y with these 2 values in it that it needs to add. All right. Now, add numbers also has a local variable called sum. And sum, we execute this, over there. We execute this and we do x, which is 5.5 plus 1.5, and we get, I need to concentrate to do that, we get 7.0. I'm going to put 0.0 just to remind us that it's a double value. Now what happens next? We've executed this line. We get to this line here. So when we get to the last line of a function, or we have a return statement in a function, that function will finish. But because we're returning some value, which we should, because this is saying this function should return a double value. And luckily, this function is a double value. this variable is a double value, right? So it's actually going to return, again, just a copy of the value. So let me just get rid of some of my messy scribble, not all of it. This is going to return the value 7.0. And the main function has decided to store that in a variable, which I should have drawn before, answer, right? So this is returned a value, the main is storing it in a variable so it can use it. Now, once this add numbers function has finished, what happens to all of its variables? Yeah, they get destroyed. That memory might be able to be better used for something else now that that function is finished. So these variables don't even really exist anymore. Well, they don't exist anymore. That function's finished, but we've got it's done its job and we've got the return value. Now the system would have kept track of where we were up to in the main function, and now it just continues. So it's going to print out the answer is 7.0. Then it's going to continue executing, and now it's going to return. We're going to finish our main function, and we're returning the integer 0. We don't have to worry who does what with that 0 that we return. Our job's done. And the 0 just means, you know, the program didn't crash. We think it ran successfully. So that's how functions work, the flow of execution, and that's how the variables work. Any questions so far? Okay, so these details are important for a number of reasons. So first of all, I kind of use the word local variable. So this n up here, I just can't use it down here. So if I try and print out n down here, let me just get rid of that. Why is it letting me do? I haven't saved it. Okay. Okay. Why isn't this letting me type? Hang on. Okay, let's try again. So I'm going to try and compile this, and it says error, use of undeclared identifier n. This is because n's a local variable that can be used in this section of the code only. It doesn't exist down here. Is everyone clear on that? Local variables. Now, it's the same thing up here. If I try and do something with sum, it's not going to compile because sum is a local variable that can be used down here, right? Same with x and y, they can only be used inside add numbers. We don't have those variables inside our main. All right. So yeah, if we go back to the slides, and let me put them back in slideshow motion. Okay. Yeah, this is what we're talking about with functions and local variables. Now, the other thing that we want to talk about too, which is really important, because this is something we don't want you to do. And if you do this accidentally because you don't even realize you're doing it, it's actually an illegal thing and you get penalized in style. So there are things called global variables. If I've got a variable like this, int result, and it's not inside a function, this is called a global variable. And you might have done this by accident because you might have typed it in and it seemed to work and you're thinking, cool, you might not realize there's any difference. So yeah, we don't want you to use these. These are bad. And I'll explain a little bit why they're bad. But I've got one up here. So this one up here, just sitting outside on its own, it's a global variable. It can be used anywhere from here to the end of this file. And that might seem wonderful because, cool, we can use it anywhere. But it actually becomes a source of debugging, nightmares, because it can be used anywhere. We've only got a really short program here, but imagine you've got a much bigger program and you've got this variable that any of the functions can modify. It's a bit like if you've got like a communal fridge and your yogurt's gone, you don't know who's taken it. If this num has the wrong value in it, you don't know what function has, destroyed it, corrupted it, done something to it. So, add numbers can use this function. And any function, anything can be using this global variable. So you might be using it in your function thinking, okay, all right, num is equal to 10, and you're expecting it maybe to be equal to 10, and it's not. It's been modified somewhere else, and it can get it's very error prone. There's also other subtle reasons in more sort of advanced code that you might do where it's not great either. The other thing is actually you might do it by accident down here, right? This could be very easy in this example. I could type in num instead of sum, and it's going to compile because there's this global variable. I might not even realize I've done it. Then, oh, it's a different type though. Let's say it wasn't int and it was the right type. We can accidentally modify it, and then, it's hard to track down where the error is. So the basic rule is we're not allowing you to use them, and you do get a mark penalty in the course for them. Okay, is everyone clear on what a global variable is and not to use them? All right, has anyone, maybe go back and look at your code and see if you've accidentally used them anywhere. Don't worry, if it was for earlier labs, it's good, but from now on, don't do it. All right, any questions? Okay. Now, the other consequence of how we pass data into our functions also has another sort of repercussion that people aren't always aware of. So if I pass a variable, if I pass something into a function and I change it in that function, it's only changing the local copy. So again, let me just show you another example. Where's my pen? So keep in mind, I've got the chunk of memory that the main is going to use for its variables. It's got an x, which is equal to 10. We're calling an increment function, and we're passing in the value that's stored in x, which is 10. Now down in increment, this parameter is called x as well. And now it's also got the value of 10. But they're two different copies, right? It's just, both have the value 10, both are calling them x, but they're two different copies. So down here, if I increment this variable, I'm adding 1 to it. I'm going to print out that the value is 11. But now this function finishes. This variable is destroyed. And back in the main, what's our x? Yeah, it's still 10. So sometimes people, when they're starting out, are confused. They think, well, that was x. I've passed that variable into that function, and it's x, and now it should be 11, right? And we call this pass by value. It's just getting the value. It's getting a separate copy of the data. If it modifies it, that's just a modification on the copy. Your original is still 10. Is everyone happy with that? And this is how it works for ints, chars, doubles, enums, structs. They're all passed in by copy. All right, we'll see later today that arrays aren't. So it's a really important concept to understand. All right, one last thing is that we can use the return value from a function in our conditions. So if our function returns some value, we can compare it to another value, right? So I could say, I could have a condition, if add numbers 5, 10 is less than 100, do this. So I'll just show you. If add numbers, I don't know, I'm just making stuff up. See, I can do something like this. I don't have to store it in a variable and then compare the variable. I can just do it all in one line like this. And this can be really handy with our scanf. So we're often in a situation where we're trying to read in data using scanf, and we want to finish. When do we want to finish? Often, like if I'm reading in integers, I might want to finish when somebody types in something that's not an integer. Anything else that would finish the input? Have you looked at Control D in Shoots and Labs? Yeah? So often we want the user to be able to type in data and then press Control D to say, that's it, no more data. Okay? So to do these types of things, we're always checking the return type of scanf, right? So I'll just get rid of this. So if scanf, if we do a scanf %d, we're trying to read in one integer. If scanf returns 1, it means it's successfully read in one integer. If scanf doesn't return 1, it means, well, maybe you typed a letter or something that's not a digit, or maybe you type Control D, and then it's going to stop the loop. So for me, the easiest way to write these loops is like this. Just in one line, I can go, do my scanf, see if it worked, and keep going if it did. Okay? Does this make sense? So I'll just run it. And in this code that you can have a look at later, I've shown you alternatives that you may have seen before or that you may have written yourself. These all involve a little bit extra code. I'll let you look at them, and like if that's your preferred way of doing it and that's what's clearer to you, do it. I personally find this the easiest one for my brain. And it's less typing, so that's good for me. So just a reminder of what this kind of thing is going to do. I can just type in integers. I can even type in lots of integers on the same line, right? And press it all in at once. And that's actually going to be read in, oops, I've got the wrong one here. That's going to be read in by different, like scanf %d will read in that one. When we go through the loop again, it'll read in the next one. And in the Shoot and Lab this week, I think you saw the term buffer, the scanf buffer. So basically what we type in gets added to a queue that scanf then just goes and reads the next integer or the next character from. So it can handle us typing in too much, and then it'll go through and get them. Also, somebody asked me the other day, what about if I type in a double? Well, if I typed in like 123 point whatever, what's going to happen? What's scanf going to do or think? Yeah, it's going to read the 123 because that's an integer. And then the next scanf is going to go and try and read an integer. What's it going to get? The dot. So all the stuff it hasn't read in yet will be in that buffer. It'll read in the 123 and go, yep, great, 123. It'll try and read in the dot and go, no, and it'll stop. So it reads the 123, it gets to the dot or full stop and or decimal point, whatever we're calling it, and it's going to stop. Okay. All right. Any questions about functions before we move on? Okay. Oh, and this is just my picture of what I already explained. Okay, this stuff here is just really cool shorthand. You don't have to use it, but you'll probably want to. Instead of writing count equals count plus 1, you can just write count plus plus. Instead of writing count equals count minus 1, you can just say count minus minus. A few people, if you've seen code around, you might have seen people doing this already. You can also do something slightly different. You can use count plus equals something. So for things that aren't just adding or subtracting 1, you can use plus equals. And it just saves you basically typing in the variable name again, really. But when we're doing lots of code, we like this type of thing. Now, if you forget to do that and still do it this way, it doesn't matter. It's just an option for you to do. I'll be doing it a lot. It's not something crucial to worry too much about. All right, one more thing that is, again, sort of shorthanded to make your life easier is something called a for loop. Hands up who's seen for loops before in, okay, so this, if you've seen them in other languages, you know, the syntax and the way it works is going to be slightly different. Here, as the cartoon sort of shows you, a for loop is identical to a while loop, except we type it in slightly different, but it does exactly the same thing. And we often use them in situations where we've got a counting loop. So those situations where you've got a counter, you're going up to less than some limit, and you've got something incrementing something. So this is what we do. Instead of using the keyword while, we use for. And we initialize our counting variable here in these brackets, which looks a bit weird at first. We've got our condition in the brackets, which is what we do for while loops. And we've got our increment here, which again looks a bit weird because usually in a while loop, we'd have it at the bottom. Okay. Even though we type it in like this is only done once, and this is done at the end. So the reason why we like to use for loops, they're just kind of more compact, and it just reminds us to both increment or update our variable. We don't accidentally forget that as often if we use a for loop. And we don't accidentally forget to reinitialize our variables with for loops. So it's exactly the same thing. If you just want to use while loops, you can. These two are exactly the same things. The while loop on the left and the for loop on the right, exactly the same things. Any questions about that? All right, so I'll start using them occasionally. See how we go with them. You can use them if you want to. Okay. All right. So now we're going to start looking at arrays. I'll just open my drink. All right. So what if we wanted to store many related values of the same type? So imagine, I don't want to start stressing you out already, but imagine I had 1,100 final exam marks and I needed to store them somehow. How could we do it with what we've learnt so far? 1,100, I can't even say it, variables, double variables maybe. How else could we maybe do it? Well, we could try and use a while loop, but what are we going to store them all in? It just say we haven't done arrays, like, and you don't know about them. What about a struct? How would a struct work? would we have to type out 1,100 fields in our struct? Yeah, so we don't want to do that. We might as well, in that case, have 1,100 variables. So an array allows us to have one variable name, but can store a whole collection of data in it. So it's really powerful. So if I've got something like this, and this is just 7, right? The number of chocolates eaten in a day, and this data isn't true actually. I can honestly say I haven't eaten 7 chocolates in a day for a long time. All right. If I've got something like this though, there's a lot of repetition in creating those variables. And again, it's only 7. Imagine with 365 or 1,000 and 100. But also it's the logic and the processing and the interaction with those variables. If I wanted to go through and print out the days I ate too much chocolate, like more than 3 or more, I have to go through each individually, each variable. Is day 1 greater than or equal to 3? Is day 2 greater than or equal to 3? I've got to do that if statement individually again and again for every variable. So can everyone see that this would be horrible to do? Yeah, good. So in computing, you'll hear this term again, data structures. So a data structure is just a way of organizing and storing your data so we can use it efficiently and access it efficiently. So in this course, we're going to learn about 2 data structures that allow us to store, these large collections of data. So one is arrays, which we're doing now. And then in the second half of the term, after Flex Week, we do something called linked lists. Then when you go on to do more computing courses, you'll learn more data structures. Now, data structures, there's no one universal best data structure. It depends what you're using things for, right? So the arrays will be fantastic in one situation. Linked lists might be better in another. Later on, you'll learn different ones which might be better in different situations. But these are 2 really important ones. All right. So arrays. I'll tell you about this. It mightn't mean so much until I show you what they are, to be honest. But unlike a struct, they're a collection of variables of all the same type. So we call that homogeneous. So in a struct, you might have a double field and then an int and then, a char. You can have a mixture of whatever in there. When we've got an array, it's a collection of all the same type. You might have an array of integers, an array of doubles. You don't mix up the types within the array. It's a contiguous data structure. Who knows what the word contiguous means? It just means next to each other, right? Packed in next to each other without gaps, not scattered around. A little bit like continuous, but like a contiguous space next to each other. So all the data is in consecutive pieces of memory. I guess a little bit like the chairs in a row, like if everyone was here, you'd all be packed in next to each other. But we don't have one chair here and another chair out there in another space. They're all packed in. It's a random access data structure. So as a person, if I was trying to walk from one chair to another, I'd probably have to walk past all the other ones to get there. It'd be slower for me to go to the back row and go to the chair there, very slow, compared to the front row, because I can't teleport. With arrays, it doesn't matter where in the array it is, beginning or end. The computer can just go directly to whatever piece of data you want and get it out. It's not slower to get from any part of this array. And it's indexed. We have one variable that stores our hundreds or thousands of pieces of data, and we just use indexes. I want the one at index 10 or index 100, and it can just go and instantly get whichever one we want. So how do we declare these things? This is how I've declared an array of type int. I'm saying I want this array to store integers. I'm giving it a name. This is a variable name. We've now got a variable called chocolate eating. Maybe it should be chocolate eaten, but it doesn't matter. Int chocolate eating, and I'm asking for it to be of size 7. 7 because there's 7 days in the week, and that's what I'm using this array for. So this is going to give me a chunk of memory big enough to store 7 integers. Okay, and when I do it like this, I'm not giving it any values. So this chunk of memory is completely uninitialized. It's just got garbage in there. Anyway, we haven't given it values. Now, the next slide here, I've set it to values. So I might know the values I want in my array in advance. So in this case, I've just written them out like this, 4, 2, 5, blah, blah, in these curly brackets. So that's going to create the array of size 7 and fill it up with that data I've put. Okay. This one here, this is like a nice trick. As soon as you use these curly brackets, it will initialize anything you haven't given a value to 0. So if I just put these brackets, it'll just set everything in my array to 0. Okay, and that's sometimes something we want to do as well. All right, this is another finer detail. If you're going to initialize the data like this, you've got to do it at the same time you declare it. You can't declare it, then later on go and set all the values in one line like this. But don't worry too much about that for now. Okay, this is how we often visualize our array and draw them. So in the course from now on, you'll often find yourself as you're trying to do problem solving, getting out a pen and drawing an array and drawing the little indexes and thinking about what you're doing, rather than just rushing straight into code. So anyway, this is what it's going to look like visually. So it's contiguous. All these variables are chunked together. We've got our 4, 2, 5, blah, blah. They're all ints. And if you notice, these are the indexes. Our indexes start at 0 and go to 6. So you'll make this mistake so many times if you're just starting out, thinking that there's an index 7. So the size of the array is 7. Is there an index 7? No, that's past the end. In computing, we often start counting at things at 0, and our array indexes start at 0. So you're often going to be off by 1, but that's just something that you'll get used to. Yeah, question?
Things like overflow work with the array indexing, so if you put it at 7, will it go back?
So the question was, if we put it at 7, if we tried to go to index 7, would it like wrap around and go back to the beginning, sort of like overflow? No. So with this, DCC might warn us if it notices we're trying to do something like that at the compilation stage. But if we run it, it's just going to crash, most likely. I thought I did, didn't I? I think I tried to repeat the question. I hope. I don't know. Okay, hang on, I'll just finish this one. I think I tried to repeat it. I don't know what I've said, to be honest. Yeah, so it's going to give you a runtime error with DCC. It's going to say no such index 7 or something like that. I'll show you in a minute. If you're using other compilers, it might do something worse. It might actually let you access memory you're not supposed to, and it might let you write over that. And this is a way that hackers used to exploit a lot back in the day. They still do now, but it used to be really common before everyone got onto it a bit more. Yeah, by these sort of, we call them buffer overflows, or when you go out of the bounds of an array. So you've got to be careful not to do that. DCC is this going to crash our program before we can try and hack into anything? I mean, it's not that easy. Yep, what's the question online?
The question online is, if you make an array of size 5, but you declare it by having like the curly braces, but you only put 1, 2, 3, and 4, what will happen?
Okay, so if we did it like, if just say I did something like this, for example, yeah, that will actually fill it up with the numbers that we've specified and then just fill everything else up in the array with zeros. Okay? If on the other hand you put too many, the compiler is probably going to say, hang on, you've got too many numbers in this array of size 7. If you don't put any number here at all, it'll just make it exactly the right size for what you've suggested here. Okay, any other questions before? Yeah?
Can you have a while loop update the variable in the, what they call it, array itself? Or give it more values?
So we just had a question, can we use a while loop to go through the array, basically?
Like say the,
And to update the values and give it more values?
like say x equals to x plus 1, but this time it's the variable in the array.
Yes.
And that while loop will give it 0, 1, 2, 3, 4, and so on.
Yeah, so the question was, can we use a while loop to go through the array and modify things? And we'll see an example of that later. Yeah, that's exactly what we want to do. We don't want to have this array and then just go through it manually, right? Yep. Oh.
Is there negative number indexing in C?
No. So is there negative number indexing in C? I'm so bad at repeating the question, aren't I? No, there's not. So in other languages, maybe you've seen Python or something, but it doesn't happen in C. If I put in -1, DCC might warn me, or it's just going to crash. Yep.
Can you initialize an array of array?
Oh, can we initialize an array of array? Yeah, and we'll be doing that next week. An array of array is like a 2D array, and it can represent what you might think of as a matrix or a table or something. But for now, we're just going to get onto the basics of this 1D array. Okay, we're going to need a break in a minute, but just give me 2 more minutes. So how do we access individual elements in this array? We use our indexes. So if I take the name of my array and say, go to index 2, then I'm just going to index 2 and I'm accessing this element, either to get the value out of it, change the value, whatever. So the thing to note with this is that we do start our indexes at 0, all right? So if I went to, how would I get this element? What index would that be? Yeah, 5. So I've got it drawn here so I can see that this index would be 5. So I'd say chocolate eating at index 5. If I said chocolate eating at index 7, crash. Or maybe compiler warning. Okay. And I'll show you that runtime error after the break, what happens. Look, let's have a break and we're going to come back and really get into the details of these arrays. Now you've got a sort of overview and get into the coding and the exact details and do some while loops with them. All right, so let's have a 10-minute break. All right, welcome back from the break. I hope you got up and moved around a bit. had a drink or something to keep your energy up. So we're just going to go into more details about arrays. So we can't just printf a whole array like there's no percent print array. We have to go, and somebody's already suggested perhaps loop through and print out the array element by element. You can't scanf a whole array. We'll talk about strings, which are different kinds of arrays later, but in general, we can't scanf a whole array. We've got to go through the individual elements. You can't assign a whole array to another. With integers, you can say int x equals y if they're both ints, right? We can't do this with an array. We can't just have an array, have another array, and say b equals a. It's not going to work. We would have to create an array and then copy all the elements individually one by one. So again, you might, create your beautiful array, which might be, thousands of elements. We're not going to go and print it out like this. Now, this is going to work, and you might get away with copying and pasting and repeating the code for a small array. But honestly, if it's 1,000 or 1,000,000, it's just, is there a better way? Yes. So we can use a while loop. Now, the reason we can use a while loop is each time, if we look at the pattern here, we're just always printing. We're going to index 0, then 1, then 2, then 3, then 4, then 5, then 6. That's the pattern of indexes we're accessing. That's a really easy pattern for us to make with a while loop. So hopefully everyone can imagine how you'd write a while loop just to get the numbers 0, 1, 2, 3, 4, 5, 6. So we can just use that variable for our index. So let's have a look. We would do it like this. And also with while loops or loops, it's really common and okay to use I as our variable because it's just a very common thing in computing. So it does actually have meaning. I index for loops. All right. So we're starting at 0 because remember our indexes for our arrays start at 0. We're going up to less than 7 because there is no index 7. We don't want to go to index 7, we want to go to less than. And you'll accidentally maybe make mistakes and put an equals here sometimes, and your program will crash. All right, now each time we're just printing out the name of the array at index I. But index I keeps changing. So the first time around, we're printing out the one at index 0. So we'd be printing out the 4. But then we increment I. And now we're printing out the one at index 1. But then we increment I again. And we're printing out the one at index 2. When we keep incrementing it, we're printing the one at index 3, index 4, index 5, index 6. And remember, I++ is our new shorthand for just I equals I plus 1. And when we get to here, we increment I. It's now going to be equal to 7. And our loop is going to stop because 7 is not less than 7. The loop stops. And we've gone from the beginning to the end of the array. And we call this traversing the array. So in this example, we've traversed or traveled through all the elements in the array to print them out. But there's lots of different code that you're going to write that has this exact same pattern that basically traverses the array, goes through one by one, and does something with that element. Whether it's printing it out, changing it, adding it to a sum, whatever. This is a common pattern that we're going to see. We're a bit early on I should stop putting that slide in. I never time it exactly right. Let's have a look at some code with just arrays. Okay, so I've got my chocolate eating array that we just saw. So, you know, if I was just printing out one thing, and we're just going to hard code things at the moment, if I wanted to print out the element at index 1, well, each of the individual elements in this array are ints, so I'd use %d, and I would say chocolate eating at index 1. And what's that going to give me if I print this out? What's the one at index 1? What value is at index 1? The 2. So yeah, don't forget that when we do this, we have these indexes from 0 to 6. So actually we're going to have the 4, 2, 5, 2, 0, 3, 1. So we should get the value 2. Oops. Let's see. And you can always play around and test your understanding by doing stuff like this with computing. What happens if we print the one at index 7? Let's try that to see what will happen. So hopefully we know that there is no index 7. I've told you this might give a warning when we compile it. It does. It's warning us it's past the end of the array. Now, if I want to, I can ignore that warning and run it. Now, we don't usually want to, right? Ignore the warnings and run it. But when we do that, I'll get rid of this array. It's going to crash, basically. And the reason is we're going past the end of the array. All right, so not a good idea. Any questions about that? So there's no index 7. It's going to warn you not to do it, perhaps. If it doesn't warn you or you do it anyway, your program will crash. How could I get the sum? Again, we're just doing small hard-coded examples before we go on to loops. How could I get the sum of the first and last element? So what's the index of the first element? Everybody? 0. What's the element of the last element? What's the index of the last element? So I heard two kind of different answers. Both were correct. So 6 in this case, 0, 1, 2, 3, 4, 5, 6. Index 6 is the last one. We might also, because I've got this hash define up here, days in week, which is 7. More generally, you can take the size of the array and minus 1 to get the last index. So yeah, let's try that. In this case, that's the same as 6. But more generally, that can be helpful if we're not sitting here just visually looking at things. I should probably print out the sum. So we're just summing two elements. And we should expect to get 5, right? Okay. All right. One more. How could I modify the middle element and make it 99? So the middle element, again, we want to basically put a 99 here. How could I do that? What index is that? So yeah, there's two ways again we could do it. We could just, that we can see as people that's 0, 1, 2, index 3, right? So I could say chocolate eating at index 3 equals chocolate eating at index, oh no, equals 99. Sorry, I forgot what I was doing. We could go through and just do it like that. Yeah, that's going to set it to 99. More generally, yeah, I could get the days in week and divide it by 2, like the size of it. Is that going to work? So in this case, if I do days of week divided by 2, what's 7 divided by 2? And in computing, what does that mean? 3. 0, 1, 2, 3. Yeah, so if we've got an odd number, that division is going to work to give us the middle element. What if we've got an even number of elements? What even is the middle element then? So look, if we did, yeah, for even, it's still going to give us one of those middle elements. So yeah, we could do that as well. Days of week, days in week divided by 2, more programmatically. So how can I print out all the data? Well, we just kind of covered that and we did a while loop. So remember, let's just do it again. I'm going to have some kind of counter because I want to start at index 0, right? And I want to continue while my counter is less than basically the size of the array. So again, in the slide, sometimes I hard code numbers just to illustrate the point, but we always want to use these hash defines when we've got them. And at each point, I'm just printing out the current element in the array. So that would be chocolate eating at whatever current index I'm up to. Then I increment my counter to move on to the next one. Does anyone have any questions about this loop? We went kind of through it in the slides, but do you want me to go through it again? All right, so let's print out our simple array. And yeah, I've changed one of the values to 99. Okay. All right. Now, what's going to happen if I start printing at 1, if I do my counter from 1, well, I'm not going to get all my elements. I'm going to miss the first element. So this might be something that you might do if you forget the indexing. The other thing that is really common again, we just see the size of the array is 7 and we do a less than or equal to. This is going to do what? If I change it to less than or equal to days in week. It's going to go through and print all of them out. It's going to go one far and go one past the end. It's going to check index 7, which does not exist. So DCC is trying to warn us, but we ignore it and our code crashes. I'll leave you to try it and read the exact error messages, but basically it's telling us you've gone past the end of the array. All right. One last thing. How do I actually, imagine I wanted to read in a value and store that as the second last element, why not? So how do I read in the second last integer of this array is the one at index 5, also known as the one as days in week minus 2. So this is the element in question, and that's an integer. So we use scanf %d, and that's the element I want to read it into. What else do I have to add for scanf? The ampersand, Okay, we're not error checking here today, right now with this. So this should allow me to go and modify, and I haven't, I might put a print line here so it's easier to see what we're doing. And I might actually say, so I know I'm supposed to type something in. And to check if it worked, I might want to print out my array again. Now this again is where we're starting to copy and paste code that's identical. We're not even going to change this, right? We're just copying and pasting it, it's identical. So let's compile it. Oops. I've got this, and because I've copied and pasted it, I've already declared an I, and I can't declare the same I, again. So I've got rid of that. Okay, enter a number. I'm entering a number to replace the one at index 5, I hope. Let's make it minus, I don't know, 7. Yep, and when I print it out, I can see that that has been replaced. All right, so these are all the just, yep.
Just before you keep going, can you chmod the file? So
Oh, this one's not chmodded. Oops.
your arrays settings.
Okay, cool. So this is not something you need to know how to do in this course. Oh, I might need to go in as well. I'll come back in. Chmod. Okay. Okay, sorry about that. Is there anything in this code so far? These are just the basic concepts that you want me to explain again. Yeah?
If the arrays are char type, then what is the default value? Like for integer we have 0, but if it's char,
If we had a char array, what's the default type? It'll still be 0. Remember, our chars are still stored actually as integers. But we'll see next week, char arrays can be special. That's how we're going to be storing strings, and there are a few little tricks that make them a little bit different. Yep, so I'm purposely not covering any char arrays today because they're a bit of a special category. All right, so that's a good question, and I'll get into more detail next week. Any other questions? All right, we're going to continue doing some more coding. We'll do some of these. Now, we've already written code to print an array, which I'm going to steal and copy and paste. Now, in this example here, okay, we're looking at a new example. I've got 3 arrays. In the first one, I've hard-coded these values in, right? So my array for numbers, let's just draw it, is going to look for numbers, I don't know if that's the right size, 2, 5, minus 8, 4, 1, 9. Oops. Okay, that's very messy. What about this one? This one's called more numbers. What's the size of it? I've got horrible hash define names. It's of size 4. What's in it? It's undefined. We shouldn't go accessing these values. If we do, I think with DCC it will crash. It'll say undefined, uninitialized, I should say. This one here, actually, this won't have zeros in it. It's going to have just undefined, uninitialized junk. But if I put this here, this is going to be an array with 10, of size 10, filled with zeros. I think that's right. Okay, is everyone happy with those definitions of what data we actually get from those 3 different ways of declaring variables? Yep.
just one question. You said that when you want to access the one that one more number size more, you said that system is going to crash. But don't usually just give us some numbers or the digit that we're storing in memory?
So this is a good question. If I access data or a variable that's uninitialized, and I personally haven't given it any data yet, on other compilers, yeah, it might just give you a garbage value that was sitting there before. Yeah. it might just give you a garbage value that was there before. DCC will step in and do a runtime error to tell you, hang on, you haven't initialized that. So you don't end up accidentally using, you know, it's a bit like sitting down at a table and accidentally picking up a drink that somebody else was drinking before that's just sitting there. And you didn't realize. It's going to warn you. Okay. All right, so we're going to print out numbers. And numbers, the size of numbers, I've got a hash defined for that. And I've got to put int here. So the first thing we'll do is we'll just change this, quickly change it to a for loop instead of a while loop. So we just get used to for loops. Is that okay with everybody? We'll see how we go. If you hate it, I can change it back to a while loop. So I literally changed the name for from while to for. I just take this thing here where I initialize it, I stick it in here. And they're separated by these semicolons. And instead of putting this at the bottom, I now stick this in here as well. So I just move those two things into that top for part. And it's exactly the same thing. As you get used to it, it's just more compact. Now, does everyone look at this and think that's much more confusing? Probably because you've just seen it for the first time. All right. I'll change it back because we're only just seeing arrays for the first time. So let's make it the one that you're more familiar with. All right. Now, how am I going to find, if I wanted to go through this and find the sum of all the elements in my array, how would I do that?
Initialize sum and then do a while loop and then sum plus equals that.
Yeah, who answered that? I could hear you, but I wasn't looking. Was that you? All right. Yeah, chocolate. Very good. If somebody feels they were robbed of a chocolate during the lecture, come and tell me at the end and say, hang on, I answered a really great thing, or I asked a really good thing. So yeah, we're going to basically initialize, first step, we're initializing a variable called sum. We're going to initialize it to 0. But then we're just going to traverse the array, go through it one by one from beginning to end. Instead of printing it, we're going to add it onto our sum. So again, this pattern that we see, I should type it again, but I'm not going to. Instead of printing this, I've still got the same loop structure. I'm still going from index 0 up until the last index, but I'm just saying let's take the number out and add it to our sum. And yeah, you could use plus equals, but I'll leave it like this for now. So is everyone happy with that? Once you can do this while loop, you can solve lots of problems with this. Now, if I want to find the average, well, I could do another loop to find the sum and then divide it, but I'm just going to find the average all at once. So I'm going to do double average equals sum divided by however many numbers I've got, right? Yeah? And then I want to try and print them out. So the sum, the average, can anyone foresee any problems? Let me. Oops. So it's complaining that I'm not using these arrays yet. So for now, I might just comment them out, just so we don't get those warnings. And I might get rid of this scribble. Actually, my whole picture is scribble, really. Now I'm getting the average is 2.0. Do you think that's correct? This isn't an array problem. So my average was 13. My sum was 13. I have 1, 2, 3, 4, 5, 6 elements. So I'm doing 13 divided by 6. I'm getting a sum of 2. Yeah?
You're only using integers.
Yeah, I'm using 2 integers. So this is just our old friend or arch enemy integer division. How can I change it in this scenario? Okay, so I've got one suggestion. I could define sum as a double. I could explicitly cast it, I think I heard. I can't just say sum point naught, But yeah, I could define sum as a double. I could do this kind of thing. This is saying, please pretend sum is a double, kind of. Let's force it to be a double. I think this is the first time where we've used it in a context where we've needed it. But yeah, you could just go and create a double variable with the sum in it instead, if that makes more sense to you. Okay. I might skip that one. Let's multiply all of the elements by 10. So again, I'm traversing my array. I'm going through from beginning to end, but this time I'm multiplying each element by 10. I can just copy and paste this. I might come back to that one. What am I doing here? Well, we treat all these, when I say numbers at index I, that's like one integer variable. So I just say numbers at index I equals number at index I multiplied by 10. Okay? And again, we're traversing, we're going along one by one. We start at index 0, and we go and get number at index 0, we multiply it by 10, and we're updating the actual array. We're going to have 20 in there. We move on to the next one. We're multiplying it by 10 at index 1, etc. We go through every element in the array. All right. Hands up if now, of course, if I print it out, if I modify it, I can't tell if it worked unless I print it out again. Okay. What have I done? What have I done? Oh, I've done the wrong thing. See, this is what happens when you copy and paste. I'd like to pretend I did that on purpose to motivate breaking this up into functions, but I didn't. But there, that's exactly why we do need functions. Oh, again, all the copying and pasting. Okay. One last thing before we do something different. How do we do a scanf with this? Same kind of thing. We've still got this basic loop that goes through beginning to end. Instead of doing printf, we're doing a scanf. And because we're doing a scanf, we put the ampersand in here. All right. One more time, I'm going to copy and paste this code, hopefully properly, to print the array. Okay, enter 4 numbers. I'm going to enter 5 numbers, 6 numbers, 6 numbers. Okay. I'm not going to do that. Okay. Oh dear. Okay, so any questions about using these while loops to traverse the array and do different things? Okay.
Can
Yep.
you say while loop it's sort of recursion?
So we don't do recursion in this topic. Somebody's asked about is while loop recursion, but no, it's called iteration. We iterate again and again.
I mean recursion is almost the same thing.
Recursion's a different thing that we're not going to do, so I don't want to talk about it, but recursion is calling functions again and again, whereas this is called iteration, but don't worry about that. Okay, before we look at functions with arrays, let's just do a quick Kahoot to remind you of all the basics of functions, and we'll come back and try and clean up our code if we've got time, or we'll clean it up in the next lecture. Don't worry, we will get through all the stuff we need to. Just to jog your mind about functions before we make it even harder. Eat them, otherwise I will end up with a tally of... I'll end up with a tally of 7 chocolates in a day if I don't give them out to people to eat. Yeah. No, you can eat them as well, as long as I don't end up eating them all. All right, so we're just waiting for people to join. Again, we get our prizes of chocolates. I'll just give you a minute or so to join. Okay, how are you going? Anyone still trying to join? The numbers are evening out a bit. They're increasing. They're decreasing. All right, let's start. Hopefully all the answers are correct. If you find an incorrect one and you're the first one to find it, you win chocolates too. Some of these might have more than one answer. Yeah, it helps us do all of these things. Okay. Fast hamster, well done. So, yeah, well, we can import libraries to use functions like printf and scanf, but we can also write our own functions. So we can write lots of functions ourselves without importing a library. Trick question? I don't know. Wasn't meant to be. All right. So this is to call a function. We're assuming A and B are actually ints though, right? Yeah, so when you're calling the function, that means you're using the function. You're asking it to run. You don't pass the types in. You don't pass the types in when you're actually using it. The blue one would be a perfect prototype for it, but that's not what you type in when you actually want to use it or call the function. All right, that's just terminology though. I can't pronounce that one, sorry, but well done. What parameters could go here instead of the question marks? Yeah, so in the prototype, we do put the types in the prototype. So we'd have int a double b. Obviously not void because we've got some inputs, and yeah, not struct mystery a, struct mystery b. It's related to, we're passing in a, which is an int, and b, which is a double. So hopefully this function, if we're going to use it, would have a prototype that would accept those inputs. Oh, I've told you what a function prototype is. Excellent. Correct. And also, I just like that picture. I think it's cute. All right. Wow. This one may be tricky. You've only got 20 seconds. I'll be quiet. Well done. Well done for people that got it right. If you got 3 plus 7 equals 10, that is a sensible answer. Unfortunately, in this question, it was a bit of a trick question. When we called the function, what did we forget to do, or what didn't we do? We didn't actually assign it to result. So the variable result, this local variable has the value 0 in it. We called the sum function, it calculated 10, but we didn't store it in our variable. Okay, so this is something that actually you might genuinely do as a mistake. Of course, you're going to run your program and hopefully see. This was pretty tricky, pretty mean, especially when you've only got 20 seconds. Next one's also a little bit mean, so read it carefully. Knowing wolf. So again, we were mean here. If you got yellow as 30, you sensibly kind of read what you might expect it to do, but we changed the value of x inside this function to 4. So these last two questions were pretty mean, and we ended up getting 24. If you wrote code like this, I don't know, yeah, maybe that wouldn't, it depends what you're trying to do, but in this example, this is pretty sneaky. That's it. Who do we have? If you're in the room, you can get chocolates. If not, tell your tutor you want chocolates, and I'll give them chocolates to give you. Well done. Hands up if you are in the room and you just won. They can have a couple of chocolates if they want. Is the last person in the room? Okay. Yeah, there's one person. Everybody duck. Again, if you're sitting at home wishing you're in the room getting chocolates thrown at you, come along, there's space. Okay. Thanks everyone. Now, it's not quite time to go. Don't get too excited. Now, we all know what prototypes are. Like most of you got that right, so that's awesome. So here are a couple of prototypes that you might use if you were creating an array, if you were creating a function to print an array. So when you're creating a function to print an array, you're just giving it orders, right? You're just saying, go and print this array. So we're going to have a return type of void. In C, there's no way for a function to know how big our array is. In C, we have to know how big our array is ourselves. We have to keep track of that. And if we pass it into a function, the function has to have some way of knowing how big the array is, right? Because most likely that function might be doing some loop and it needs to know how big it is. So one way is you might create functions that always just have an array of a set size, right? And we've got a constant for the size of that array, and the function can use that. But in more general situations, you just might want it to work for arrays of any size, but then you have to pass in the particular size. Okay, so typically we pass in the size and the actual array. And this is suggesting that you should make sure, if you say it is a size 10 array, that you pass in a size 10 array. It's suggesting that in the prototype. So here's an example. I've got a main. It's got two arrays in there. One is of size 5, one is of size 3. I can pass them both into my print array functions. I just say, print this array, it's of size 5, and here's the array. And again, when I'm passing things into functions, I don't put the type. So I'm not putting int marks brackets on this line. I just put the variable name. Here I'm just putting 3 because that's the size and the variable name. And down here in print array, when we're printing out this first one, we're going to get a copy of that size, 5. And with arrays, it doesn't actually copy the whole array. It just tells us, there's the array. Arrays can be quite big. They made a decision we're not always going to copy them. When we pass it into a function, it doesn't make a copy. You just get to find out where that actual array is. But here, okay, inside this function, we're calling this array instead of marks. And we'll explain more about the finer details of that further down the track. But yeah, in here, again, we've just got a while loop disguised as a for loop, traversing the array like we've already seen, using the size of 5 and using this array up here to print it out. So this is how we can organize our code into functions. Is everyone kind of happy with that? Or does it kind of make sense? Does anyone have questions? So we will go up and clean that code and put it into functions. Now, because we don't send a copy of our array in, when I create my array up here, I don't know, I haven't said how big this is, but imagine it's this big and my size is 4. In this scan marks, I'm passing in a size of 4, so it gets a copy of that variable, but this array is really, and this array, it's the same thing. It's like me saying, you know, I don't know, if I just go to the library and get that book, it's just like that one book, it's not a copy of it. So if you go to the library and start tearing up that book, you've actually teared up the book, right? If I give you a photocopy of the book and you tear it up, the book's going to be fine. But here, as I'm reading these in, I am doing a scanf, integer by integer. You know, maybe I type in 5. It's going to go into here. We're actually modifying a variable in this case that was a local variable in the main function. So with all of our other types, we haven't been able to do that. It's passed in a copy of our int. It's passed in a copy of our enum, our struct, our char, our double. So it's passed in a different way, and we can modify arrays from inside functions. So I keep typing stuff in. By the end of this, my array's been filled up, the one that was created in the main function. So this will become very important. Does that kind of make sense? Otherwise, if it was passed in by copy, I'd have a separate copy of that data. The original array back in the main would just still have nothing in there. The other thing is, you might be thinking, well, why can't I just create an array in my function, declare it in the function, fill it up with data, and then return that array? Something like this. Or maybe you weren't thinking that. C doesn't let us do that. That's not going to compile. And again, we'll learn the finer details of that later. That's not going to work. The way we do things is we pass the array into our function. We can modify it from there. So that's all we've got time for today. Next week, we'll go back and we'll actually go and turn that code we wrote into code that has beautiful functions to revise it. Do feedback as usual. Don't forget about help sessions, revision sessions. Have a good weekend.